Hey guys, welcome back. So we're going to be talking about titrations today, and there's a two-part to this. So there's experiment 8, which is the standardization of NaOH, and then part 9, which is the concentration of vinegar, which is the way we have to do this. Titration involves 2 steps. The first is a standardization, the second is a titration of an unknown with that standard. So that's what we're going to be doing. I'm going to go ahead and share my screen. And then I'm going to take you back into the first of these 2 assignments. Sorry. Standardization of sodium hydroxide. So I've already done this lab, but there are parts of it that I wanted to show you to make sure that you knew what was going on, how we were doing this. So bear with me just a moment while I open this up. I wanted to reset this phase. And the reason I wanted to do that is because I want to select this sodium hydroxide, and then I want to fill the burette with it. And what you'll see when you're looking at this is 1.5, okay? And it's 1.5 because it reads from top down, okay? So you're going down as you do this, right? So it's higher numbers, lower on the burette. So some burettes are listed this way, some are listed the other way, some have both. So that's a thing you can do. I mean, it's entirely dependent on the glassware that you have. But remember that this is upside down. So in my lab data, you'll see that the volume on the burette is 1.50, and it says, oh, okay, awesome. Now, like I said, I've done the rest of this. A couple other things I wanted to show you. We go to the next. Sorry, forgot to do the last part, which was to put that back. So when we go to the next part, it says to mix the KHP in here. So you measure it out, you mix it in here, you heat it, you cool it. Then it says you put the paper on here underneath this, and you add the phenolphthalein before you put it on. The reason you have to do it that way, and I've actually seen many students do this, is they'll prepare their solution, they forget to put the indicator in it, and then they go to try and titrate it, and they never hit an endpoint, and they don't understand why. And so I say, did you add some indicator to that? Now, this won't let you do that wrong, okay? But that is a very common mistake in the physical laboratories, to forget to add the phenolphthalein, and that's why you're supposed to do it before you put it underneath to start the titration, okay? So I just wanted to make sure that we talked about that a little bit. When we come to this part, when it says, when are you supposed to slow down how much you're adding? Because you can add in larger increments until you get close. Now, you should have done a calculation to tell you where you think the endpoint is going to be. I can tell you right now that it's not always there. Sometimes it comes before that, sometimes it comes after that. And so we don't use that calculation as a guide. What I do say is that if you get to twice that number and you haven't seen anything, then maybe we should look at something else to see if there's something we forgot. But it can come early, so we have to make sure that we're paying attention to that. And that's why we're looking for when the change in color begins to persist. So where we see the color form and it hangs out for a minute, okay? We'll go to the next phase. They ask us how much of this we would do. Yeah, okay. Like I said, that's walking you through that calculation that you would do. And then in this part, I'm going to reset this part so that we can see what this will look like. We turn on the stir plate. It's really annoying with the sound. We start the titration, and so we turn this little guy right here and add stuff, and then we stop. We add stuff, and it stops. Now, normally in the lab, you're doing this, so you need to be careful how you do those turns. Then we keep going, and it looks like nothing's happening. Until then, did you see that? Change in color? I'll do it one more time. and you'll see that there was pink that showed up there. Now, it's going to ask you a question about why you should now add smaller increments, okay? And there is a reason that you need to do that, and it's one of those four, okay? So make sure that that you know that you need to start adding in smaller increments. And I usually, when I do my notes, actually it should be in my observations. Oh, no, my observations are now gone. Sorry, I reset it so my observations are gone. I usually look to see where that started, and it was 25.25-ish, because this is the second time I saw it. So I say, it's after 25, before 25.5. And so in my lab data, when I'm making my observations, nothing appears to happen until after 25 millimeters and before 25.5 millimeters, where color begins to appear. Do I need to note that? No. Do I find it helpful? Yeah, I do. For me, I do. And that's why I do it. Okay, so I'm going to zoom out now, and then we're supposed to keep doing this. So do it again. Appears, goes away. Appears, goes away. Appears, hangs out, goes away. Appears, hangs out. Now it's not the same color. Now this is the endpoint that you're actually looking for. And I can tell you that this endpoint, this nice perfect endpoint that you see here, is virtually impossible to get to. Okay? I have years of experience doing titrations, and it's really difficult for me to get this unless I've done some practice recently. So when you do this in the physical laboratory, we do this until you get that endpoint, and then you get to the bar, okay? And we always do every titration 3 times to make sure that the number that we're measuring is relevant to what we're supposed to be doing, okay? We've only done it once here, so okay, fine. 26.567 8. I think that's 26.9. 26.9. And then it'll ask you to calculate it, and then you'll be asked to calculate the concentration. Now, if you don't know how to calculate that concentration, there is a guide for you, okay? Now, your balanced chemical equation they gave you, this was in the introduction. And we know that we can calculate the moles of KHP by taking the mass of KHP that was used and dividing it by the molecular weight, which was again given to you. Okay? This tells you how many moles you have. All right. Now, when I have the number of moles of that material, I can calculate the moles of NaOH. So I take that moles of KHP. I know there's 1 mole of NaOH per mole of KHP. And so that gives me the number of moles of NaOH. I can then take that number of moles and divide it by the volume in milliliters, and then convert that to liters to get that molarity that I'm looking for. Now, these are not the right numbers, so this is an idea of how you would do this. But remember that that's what we're doing. So we're going from grams to moles, from moles of KHP to moles of NaOH, from moles of NaOH to volume of NaOH, to molarity of NaOH, moles per liter. And we do that by dividing by that one. Okay, so that's the calculation that we're doing there. So you should be able to handle that. Cool, awesome. Hopefully you turn this off before you do all those calculations so it doesn't drive you crazy. So that's our standardization portion, all right? And what you'll find is that this number is not a nice, pretty, neat number. It never is, okay? That's what we're going to have to use for the next portion. Now, we don't actually use this data in the next lab, so that's going to be a little bit different. We're going to go to our assignments and go back into Virtual Lab 9, which is our concentration of vinegar. Dun, 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 dun. Takes forever to load. I'm going to scroll back and look at, and this is the first part that I want to show you. Now, filling the burette here is exactly the same as it was before. So remember that we're starting at 0 and going down. All right, we're going to reset this phase. And the reason I want to reset this phase is because we're being asked to Oops, wrong phase. Sorry. So 1.15. I didn't like that. So 1.20. When it complains about my sig figs, I always try, add some, subtract some, see what it actually wanted. Again, it's very difficult to read this because it's hard to tell where the meniscus actually is in what I'm looking at here. Okay, so that's my issue. At least that's my issue. So I zoom out, I put the lid back on, and I go to the next phase. In the next phase, I've already, yeah. What it says to do is use clean 10 ml volumetric pipette to add 10.00 milliliters vinegar to a clean Erlenmeyer flask. So we take this pipette, we put the bulb on it, we put this into the vinegar, and we fill it up to the mark. Now it's really hard to see that. There is a mark on that thing. And as long as your meniscus is to that mark, it has measured 10 mils on perfectly, as long as the glassware is good. So we then put that into our Erlenmeyer flask, and then they want us to record that. So I'm going to put this in the waste. I'm going to say, oh, okay, well, 10.00 because I know that's exactly what it is. And there we go. Okay. Now it tells me to add water to this as well. The reason that we add water to this one, so last time we needed to add the water to dissolve the KHP. This time we have to do it so there's enough volume for us to see the color change. Okay. If we did it without that, we would have a problem. All right. So from here, it's exactly the same as what we did before. Just wanted to show you some of the differences in measurements and things that we had to do. Now, notice in your lab data, it says what the standardized NaOH concentration is. All right. Now, once I find what that concentration is, I normally write it on my bottle, but they haven't done that, so that's recorded in the lab notebook for it. Okay. So make sure that you've got all your information, and you should be good. Okay. So I think that's everything with these two experiments. Again, you're doing what I consider a very nice and forgiving titration because it won't let you screw it up. Another thing I'll tell you is that when we actually do this in a physical laboratory, we don't stop at the endpoint, we keep going. And the reason we keep going is because we want to see the entire curve. There's purpose for doing that, all right? So that's something that you should be aware of. If you go to 111, you're going to have to do the entire curve. So there you go. All right. Well, that's everything I have for this one. That's 8 and 9, if I'm not mistaken. Yeah, 8 and 9. So I will talk to you guys again soon. Thanks.